Welcome Pure Maths 1 students to week 15 of maintenance. Getting a bit longer each time now. We've got a few more topics that we can add in. Today we're going to begin, of course, with quadratics, and the first one here I've got to solve the simultaneous equation. So what I'm going to do is I'm going to rewrite this first one as x is equal to 5 minus 2y, and then I can use that as my x value in the second one. So I'm going to substitute that in. I'm going to go 5 minus 2y, and I'll square that, plus y squared equals 10. And when we expand this, we're going to get 25 minus 20y plus 4y squared plus y squared equals to 10. So we gather everything across to one side, and we're going to get 5y squared minus 20y plus 5. Oh, sorry. Wait a second. Plus 15. So we bring that 10 across by subtracting. So yeah, that's plus 15 equals 0. And I guess we can divide that now by 5 to get y squared minus 4y plus 3 is equal to 0. And now we can factorize, and it looks like y minus 1, y minus 3. And so the values of y equals 1 or 3. And then when we plug those into x, and x equals 5 take away 2 times 1, so 3, or 5 take away 2 times 3, so negative 1. Now that's the first one. Moving on to functions. We've got to determine the sequence of transformations that maps the curve y x cubed onto the curve y equals 1/2 bracket x plus 5 cubed. So you can see that we've got a translation, first of all, of minus 5, 0. That's representing by this bit here. Shift to the left by 5. And then we have a vertical stretch factor of 1/2. Oh, that's a nice one. The next one is a coordinate geometry question, and we've got A and C lying on the y and x axis, and we know that the equation of the line is 2y plus x equals 16, and we know that point B has coordinates 2, 2, and maybe I'll go in a bit so you can see this. Hopefully that's a bit better. And we know that the perpendicular from AC meets from B to AC meets at point X, and we've got to find the coordinates of X. Okay. So first of all, we can find the gradient of AC, and then we know what the gradient of BX is. So gradient of AC, if we could actually just rearrange this and get y is equal to negative x over 2 plus 8. So just move the x across, divide by 2. So the gradient of AC is negative 1/2, and therefore that means the gradient of BX must be, if it's perpendicular, must be the negative reciprocal, because it's perpendicular, so it should be 2. And we know that the formula for this line BX is going to be y minus, I'm going to use these coordinates here, y minus y1 equals 2 into x minus x1. And so we get y is equal to 2x minus 4 plus 2, sorry, I think minus 2x minus 4, minus 2, I think. Okay. And now we know that this equation and this equation meet at some point. So what we're going to do is we're going to set them equal to each other. So I'm going to go 2x minus 2 is equal to negative x over 2 plus 8. Now, I probably just multiply everything by 2 to get rid of that fraction, just because I want to. Is negative x plus 16. I'm going to pull the x's over to this side, and the y's over to this. Excuse me. And then I will divide by 5, and I should get x is equal to 4. And therefore I can then substitute that value of x in over here. 2 times 4 is 8, take away 2 is 6, so y equals 6. So the coordinate should be 4, 6. Now, excuse me. The point D is such that the quadrilateral ABCD has AC as a line of symmetry. So it's some kind of kite, I guess. And we've got to find the coordinates of D. Well, the way I think of this is I go, well, BX, we've gone from 2, 2, and we've gone to x, what do we say x is? 4, 6. So you can see that the BX is vector 2, 4. Right, we've gone across 2 and up 4. So if this is a line of symmetry, this AC, then we're just going to go across 2 and up 4 again. So therefore the coordinates of D will be, we take the x and we add 2, 4 to that, so we should get 6, 10. Now we've got to find the next we've got to find the perimeter of ABCD. ABCD. Okay. ABCD. Okay, so essentially if we think about what we've got here, let me just draw on this. We'll have another one out here somewhere. Probably out here. And then like this. And then this will join it. So if we can find length CB and length BA, we can just double those and that should give us the distance. So we probably want to find points C and point A. So we know that C is on the y-axis, which means x is equal to 0. So the coordinates must be, we can use this here, must be 0, 8. That's C. And A, the y-coordinate is 0. So that means we've got 16, 0 using, again, the formula here. And that should give us all that we need because we know that B is 2, 2. So what I'm going to do is I'm going to take, whoops, daisy. I'll just, why can't I select a little bit here? I can do it this way. No, for some reason it doesn't want me to select. No, okay. How am I going to do this? I'm not. I know what I can do. I can trick the program. I'll just go like this. Okay, so here's the points. And what I'm going to do is I'm going to find length BC. So perimeter, whoops, the perimeter is going to be equal to 2 lots of, and then I'm going to find the distance between B and C. So the square root of 2 minus 0 squared plus 2 minus 8 all squared. So that's finding the distance between B and C, right? And then we want to find the distance between A and B. So that would be the square root of, I guess we can go 16 minus 2 all squared plus 0 minus 2 all squared. And we're doubling it because of course we've got the length, the other lengths like C to D and then D to A. Okay, so that's why we're doubling it. So when we plug this into a calculator, what do we get? So we've got 4 plus 36, okay, plus, and the other one is square root 10 squared plus, I'm going to times that by 2. And I'm getting, when I do 3 significant figures, I'm getting 40.9 as my final answer for perimeter. Now, the next one here, I've got this diagram showing a semicircle, and it's got a radius of 8. So, okay, so this is 8 here, this is 8 here, as you can see. Lovely. Oops, there goes the calculator. Dear, dear. Okay, now we've got to find the triangle EOF. So EOF, so the area is going to be half r squared sine theta. Make sure your calculator is set to radians, so it's going to be half times 8 squared times sine 2. And when I chuck that in my calculator, making sure that I'm set to radians, which I'm currently not, I'm getting 29.12, 3 significant figures, but I'm going to save the unrounded number there as A, just in case I want to use it later on. Now looking at fog, F-O-G, so I want to find the area of this sector here. This bit here. So I guess first bit, I've done this. I've done that bit there. That was this. Now we're doing this one here. Okay, so well, the angle FOG is going to be pi minus 2, because angles on a straight line add to pi, and we know that the other part is 2 radians, so I'll just do that. And the area of a sector is half r squared theta, so half times 8 squared times pi minus 2, and this is giving me 36.5. I'm going to save that into my unrounded numbers as well. So I'll save that as B. Now sector FEH. FEH. Okay. So this time we're looking at finding, let me colour it in with a different colour, FEH, so I've got a different, this bit here, right? That bit there. Now, what do we know? Sector FEH. Well, we probably want to find this radius here. So you can see if this is a sector, right? If this whole thing is a sector, you can see the EF is a radius of that circle. So we need to find out what that is. So how are we going to do that? Well, we can use the triangle that we used in the first point here, where we said that we've got that isosceles triangle. So we can use the sine rule there. So let's just consider for a moment this triangle. I have not drawn that very well, but that's 2 radians. We know that that's 8, and we know that that's 8. So we can use, and this is isosceles, so we could say that that is pi minus 2 over 2. And the reason it's pi minus 2 over 2 is because angles in the triangle add up to pi. So to find the other 2 angles, you subtract the 2 that you've already got, and then you've got to divide it by 2, because both of those angles are equal. Yeah. Now, so therefore we can say this one, angle FEO equals, so we're going to use no, we're not, sorry, what are we doing? We're not doing EFO. We're doing length FE. So FE, and we can use the sine rule, FE over sine 2 ought to equal 8 over sine, and then bracket, what do we work out those angles to be? Pi minus 2 all over 2. So there we go. And then we're going to rearrange our formula and see what we come up with. So when I'm doing this, I'm getting, what am I getting? Sine 2 times 8 over sine bracket pi minus 2, okay. Nope. Pop in another bracket here. And I'm getting a syntax error because I've probably stuffed something up. Oh, I think I need another bracket. There we go. Yep. And I'm getting 13.5. So I'm going to save that as well. FE equals 13.5. So the area of the sector of FEH is equal to half r squared theta. Now we know what theta is. We've just worked it out. That's the theta. And we know what r squared is. That's this bit here. So we're going to go half times r squared, which is 13.5, although I'm going to use my unrounded number, times pi minus 2 over 2. And when I do this, I'm going to calculate it. I'm getting 51.7, and I'm going to save that as well. Now we can work out the shaded region. Okay, so you can see that the bit we want is that pink bit. Now to get that, we can do pink plus green subtract blue. Can you see that? I hope you can see that from my diagram. Pink plus green, so 36 plus 29, take away 51.7. So that's what we're going to do. 29.1 plus 36.5 minus 51.7. What does this give me? This is giving me 13.9. Hope that makes sense, guys. It was a bit of a long-winded one. Now, the next one, we're doing trig, and we are trying to prove this identity. Now, my first step would be to multiply and get a common denominator. So then I would get 1 plus cosine theta all squared, and then it would be all over 1 plus cosine theta and then sine theta. Now my next line, I'm going to expand the top here. So I get 1 plus 2 cosine theta plus cosine squared theta all over 1 plus cosine theta, and then into sine theta. Now I'm sure you can see what's going on here, because this plus this is 1, so our next line is going to be 1 plus, is that right? Yeah, 2 cosine theta. Is that right? Yes, it is. Plus 1, so this plus 1 here is this and this, isn't it? So we end up with, instead of plus 1, I guess we could make this into a 2 and just get rid of that one there, couldn't we, really? Let's make this a bit neater, it's getting a bit messy. 2 cosine theta, then we're going to pop that over 1 plus cosine theta into sine theta. And then we'll expand, we'll factorize that. And we're going to pop that over 1 plus cosine theta. And you can see probably already now we're there, because we can just cancel this out, because that divided by that is 1. And that will leave us with 2 over sine theta. Okay. Now, Next one is a series question. I think this is the first time we've come across these in maintenance, but hopefully by the time you are doing this, we'll have done it in class. So we've got to find the first three terms in the expansion in ascending powers of x. So what we do with these, you can imagine, well, no, I won't go over it from the beginning because I will have done this in class by this point in time of the year. So what I'll do is I'll just show you. The first term, we'd get 5, choose 0, times 2 to the power of 5, and the other term would be x squared to the power of 0. So that's our first term. And we're wanting ascending powers of 0, so that one's to the power of 0. Then the next one is going to be 5, choose 1, times 2 to the power of 4, and then times x squared, and that will be to the power of 1 this time, plus 5, choose 1, times 2 to the power of 3, whoops, and then times x squared, and this time it's going to be to the power of 2. And those are our first three terms in the expansion. Now 5 choose 0 is simply going to be 1, and so we're going to go 2 to the 5, which is 32, yeah, wake up, 32 is our first term. Then 5 choose 1, so this one here is 5, and then we're going 5 times, what's 2 to the power of 4, 16, so that should be 80. So we're going to get 80x squared for our next term. And the next one, oh, that should be 5 choose 2, shouldn't it? The next one is 5 choose 2, which is 10, and we're going to get 10 times 8, so we'll get, again, 80, and that'll be x to the power of 4, using my index laws to resolve that there. So those are the first three terms. Now, it says, hence find the coefficient of x to the power of 4 in this expansion here. So, you can see that this bit here is the one that we've just done. So, I've got 1 plus, no, let's move it down a bit, 1 plus x squared, and then I'm timesing it by this here. And remember, they haven't told me to go any further, but it does go further, like the next power would be x to the power of 6, then x to the power of 8, and so on. Okay, but the reason they've given us everything we need here. So, we're trying to make x to the power of 4 terms in this expansion. So you can see straight away, if I times this by this, that's going to give me an x to the power of 4 term. But there's also another way that I can get an x to the power of 4 term, and that's if I times this one by this one. And so you can see that there are two ways of getting x to the power of 4. The brown way there would be 80 x to the power of 4. I think I've turned it into black now. And then the next one would be 80 x to the power of 4. So they both end up being 80 to the x to the power of 4, and we add them together, we get 160 x to the power of 4. The coefficient is 160. Okay. There we go. So that's how you do that one. Now, moving on to probably our last question today. Yes, our last question. This is a differentiation question. We are... What have we got? We've got a curve. We've got to find dy dx, and then we've got to find... Okay, right. Cool. So, you're going to get to the stage where you can just do this in your head, but I'm going to show you the chain rule here. So, we're going to say that u is equal to the inner bit there. Okay. And therefore du dx is equal to -5. And we can say that y is equal to u cubed. And then we just go dy du equals 3u squared equals, now we can reinsert the u, 3, u was 3 minus 5x, and we get squared. Now dy dx, the gradient function, is equal to du dx times dy du. You can see we can cancel those out when we're left with dy dx. So we take this and we multiply it by this. So that gives us -15 into 3 minus 5x all squared. Now, so hold your horses, I haven't quite finished yet. Okay, so you can see this is the answer we get. Now you can actually just do this in your head. You take this, you times it, you differentiate the x term in here, So it just becomes minus 5. Put that in front and then drop down the power of the whole bracket. Okay, so that's all we've done. Now, finally, to get our final answer, because we haven't taken into account this bit here, so we're going to say dy dx therefore is equal to negative 15 into 3 minus 5x all to the power of 2 minus 2. Now, that's the first answer. And now we want to do the second one, where we're trying to find the second derivative. So, for the next one, let's do this one in our heads this time. So, we're going to take this, we're going to multiply it by this, and then multiply it by the front here. Okay, so when we differentiate that, we're going to get 150. Then I take this bit here and drop the power down by 1. And that would be it, because this term drops out. Now, hopefully that makes sense. If it doesn't, what I will do is I will just show you the slow way for this here. So I'd say that u is my middle bit there, and I'd differentiate that. And then I'd say y is equal to the overall thing. And therefore dy du is equal to negative 30u. When I put it together, dy dx, we multiply this one by this one, and we get 150u, which is equal to 150 bracket 3 minus 5x. So there we go. Another week in maintenance. Hope this is helping. Hope that you're feeling more and more confident as we keep practicing these skills. God bless, team.